In this video, we will learn how to compute probabilities involving two dice. An ordinary fair die is a cube with the numbers 1 through 6 on the sides, represented by painted spots. Imagine that such a die is rolled twice in succession and that the face values of the two rolls are added together. This sum is recorded as the outcome of a single trial of a random experiment. Compute the probability of each of the following events. Event A, the sum is greater than 5. Event B, the sum is not divisible by 2 and not divisible by 6. Round your answers to 2 decimal places. Since we have two answers to find, two probabilities, I provided here two tables containing the entire sample space of this experiment. There are 36 possible outcomes when I'm rolling the die twice. Each pair here indicates that I am recording the outcome. For example, if I grab, let's say, this pair here, it means on the first toss we got 4, on the second one we got 2, and the sum of the two outcomes is 6 in this case. I would like to know the probability that I get the sum that is greater than 5. We are going to record it like this. Probability of event A is same as probability of getting the sum that is greater than 5. What are the sums that I could get in this experiment? Well, if we look at the table, the smallest sum I could get is the sum of 1 and 1, which is 2. And the highest sum I could ever get is the sum of 6 and 6, which is 12. So my sums runs anywhere between 2 and 6. I am only interested in the events that have sum greater than 5. To be able to find how many of those sums meet this requirement, I'm going to look at the diagonals. Luckily for us, this table is very symmetric and makes it easy to track down the right number of that sum. So let's take a look. Where are the sums that are greater than 5? I see right here 4 and 1 is equal to 5, 3 and 2 is equal to 5, 2 and 3 is equal to 5, 1 and 4 is equal to 5. So all of these are not part of my event here or anything before. I am only interested in this diagonal with 5 and 1 and 1 and 5 as my first and last entry. So I'm going to highlight that. This sum of the pairs in this diagonal is equal to 6. The next one is equal to 7. The next one is equal to 8, and then 9, and then 10, and then 11, and finally 12. All of these sums are greater than 5. How many outcomes are there altogether? Well, using this table, it's pretty easy to compute. There are 5 along the first diagonal, 6 along the longest one, and then numbers decrease 5, 4, 3, 2, and 1, which means the probability of getting 6, 7, 8, 9, 10, 11, or 12 can be computed by adding 5, 6, 5, 4, 3, 2, and 1, and that sum will be divided by the total number of possibilities, 36 of them. When we add all those numbers in the numerator, we will get 26 altogether out of 36, which is approximately 72/100th, rounded to 2 decimal places as directed. Our next task is to find the probability of event B, which is described. The sum is not divisible by 2 and not divisible by 6. Probability of B is same as probability of the event that sum will not be divisible by 2 or 6. It means that I cannot get even numbers. Only odd numbers can work for us this time. So probability of getting 3, 5, 7, 9, or 11 as the sum. If you look at the table, I already highlighted diagonals that give me sum of 3, 5, 7, 9, and 11. There are 2, 4, 6, 4, and 2 such events, which we combine together to get 18 outcomes out of 36 possible, and that takes us to the probability of 50/100th. Please make sure to write your answer to 2 decimal places so that 0 is significant in this case because of our directions. Here is another example. The story is the same, events are described differently. So I'm not going to read through the directions again. They're identical to the previous slide. Just let's take a look at what we're asked to find. Event A, the sum is greater than 7. So probability of A is same as probability of the sum being greater than 7. Just like before, let's take a look at our table and see where and how many events we have that meet this requirement. 7 is across the main diagonal from this corner here to that corner there. I cannot use it. It has to be sum that is bigger than 7, or 8, 9, 10, 11, 12. So I'm looking for 1, 2, 3, 4, 5 little diagonals. Let's take a look how many events there are. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 events in this case. I would like to expand this and say that the probability we're looking for in this case is the probability of the sum of 8, 9, 10, 11, or 12. Those are the things we're going to include, and as we already counted them, there are 15 out of 36 outcomes that meet this requirement, with this, which is rounded to 2 decimal places, is 42/100th. Our next event, event B, probability of event B is same as looking for the probability that the sum is an even number. All right, which is same as probability that the sum is, okay, even numbers between 2 and 12. 2, 4, 6, 8, 10, or 12. Now let's take a look at our table to see how many events meet this requirement. Sum of 2, there's only one outcome that meets this requirement if you on both tosses got 1 and 1. 4, we have 3 events like that. 6, we have 5 events meeting this requirement. 8 as the sum, 5 again, 10 as the sum, 3, and then 12 as the sum is only 1. As you can see, there is certain symmetry to it. 1 outcome, 3 outcomes, 5 outcomes, 5 outcomes, 3 outcomes, 1 outcome. So that's how I can find that probability. So 1 plus 3 plus 5 plus 5 plus 3 plus 1 out of 36 possible outcomes. Together, this gives me 10, 16, 18 out of 36 again. So we have 18 out of 36, or 1/2, or to 2 decimal places, 50/100th.